Oh, marvelous. Marvelous quartet. I put so much into this. I started the paint rust treatment. I got to sand some more and do some more paint. Make it look decent here, but I think we're going to recover the panel. I had to build a lot of these things here. The switches are working again, but a little sticky still on some of them. Goop is drying. I made pads because all that stuff was shot up, of course. So letting that stuff completely dry over the next day or so. That's out of a Thomas organ, or a Lowry, I'm sorry. And that one's an original. And those are ones I had in the drawer from I don't know where. And another organ one. Got decent sliders in there. We'll get the knobs matched up on those. This machine just was smashed and busted to pieces, and it just, I just love recovering completely dead things sometimes. Of course, this one has a oscillator coil here, and that's the 5242, or is that no, it's a CD4069 buffer for the clock, and then you've got your 5242 MOSTEC chip there, and then a bunch of TDA 1008 dividers slash. They have a control leg for sustain control, and of course there's your BBD array there for the chorus effect. Let's see, this thing has an OTA somewhere. There it is. Yeah, there's the filtered OTA there. Now, I've got a very peculiar problem here. Everything's working now. I had some of the through holes. Beware on these things, folks. The through holes are terrible, and they can create... I was tapping here and going, oh, it's over here. No, it's not over there. And tapping, oh, it's over here. No. Just deceiving me and making me think that there was a bad socket or something here initially. But in reality, I just had to solder all the through holes on this side of the board, and that got it. It stays in brass mode now. Everything's working lovely there. What is not working is we have absolutely no sustainer. Now, the sustainer, there were various problems. Somebody clipped the resistor out, thank you, the 1K resistor here. Now that is part of a reference leg, right? But yeah, that's the voltage divider that makes just a reference voltage for the sustain. And over here, though, is this op amp that both buffers the sustain, or the reference, and it buffers the actual slider. So when you move this slider here, it should change the voltage, and it does. If I pull this chip out, you will get sustain. It sustains long if you pull the chip out and you're measuring 0 volts on pin 1. 0 volts on pin 1 gives you long sustain. It's got 2 volts currently. That gives you no sustain. Interestingly, we have a variation of a little under 2 volts to like 3 volts coming in on pin 3 here, and I can show you that on the scope if you'd like, just to prove that I'm not kidding. This thing seems demon possessed. I've really never seen this happen because this is the simplest op-amp circuit, and I have verified measuring between pin 1 and 2. They are short-circuited. You can see underneath. I redid all the solder just to make sure everything's fine. Now, the power supplies do not sag. There is plus and minus 12 volt or so on each of the pins for the pin 4 and the pin 8. And you'll see the scope it move up or down on pin 4, and of course up on pin 8 off the scale there because I'm on 2 volt scale, so that's over 12 volts. Anyway, a little over, not much. It just barely goes off scale. So that's measuring from there, you see, and then to there on the negative side, pin 4. Okay, so meanwhile, pin 3 here, I'll put it on pin 3. Okay, there we go. So there's pin 3. Now I'm going to try to show you as I move the slider here what it does. I'm going to move it all the way down. Now it's up there. Okay, so it changes from about 3 volts on 2 volt scale there to a little under 2 volts. Okay, and I think you can see that hopefully. Yeah. Alright, but regardless, now I'm going to put it on the output pin here and you will see the strangest thing. You know? Let me get it to stay. There it is. Okay. There's your voltage, a little under 2, okay? Now I'm going to move the slider all the way the other way, still a little under 2. It doesn't move a bit. Not a bit. Now, any engineer out there, tell me how that's possible. Okay, you've got the simplest circuit. This is a follower. This is a buffer. Tie the inverting side back to the output. Then you have a follower circuit where the op-amp will create a situation where you have up to whatever the limit is on the op-amp, typically 10 to 100 milliamps or whatever of current. So a lot more current to drive other circuitry, which is what this needs to drive the sustainers in the TDA 1008s under the keyboard. So that is where that goes to the sustainers after that. But I mean, I've checked this thing and there is nothing wrong underneath. I resoldered everything. There's nothing shorting or anything. But what could be? Anybody have any ideas? I'm puzzled. This is what I've been facing constantly of late. I get to the end of a project and something stupid like this is waiting there to hit me in the head with a hammer. I'm telling you. It's just horrendous. I thought this thing worked before and it had a bad regulator. Right, these are the UA78MG regulators, and they can be programmed to different voltages. That's 6 volts and 12 volts on the other plus and minus of each, coming out to these points. So these things aren't too bad to work on. They got some good test points here. You can check your power supply real easy, and then you know, once you understand this is board F, this thing here is board F. And this is board B. I write that on there, and they designate the parts like IC-B1 for IC1, and they number them. This is actually IC2, IC1, and then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on that board. And then on this board, I think it just goes straight, except for that one. That's IC16. This is 1, 2, 3, 4, 5, 6, 7, 8, or 8, 9, 10, 11, 12, 13, 14, 15. Yep. And so once you've figured out where those are, then the schematics make sense a little more, because it's a little different way of designating things. ICB or ICF2 is the board it's on. That's the F board down there. So yeah, the ARP Quartet is otherwise pretty straightforward usually to work on, but this thing, typically you get a lot of bad. See, I wired these because these go bad. The pins break off in there. That's a very common problem on these. That and the through holes, like I said, these through hole things that they do not. It's a board that's made of insulated material, and they only laid material that's conductive on the surface. So they had to use they use these coils that go through there, and sometimes they're quite dirty. You have to flux and rub them to get them to come back. So beware of that if you ever work on a CL thing in general. CL is famous for that. I guess Krumar did some of that too. Well, this used to be a really ugly thing. Now it's only partly ugly. I gotta still put some new facing on those. There's some new veneer. And paints a little bit. Yeah, a few places I need to smooth still. And I rebuilt all this thing. I mean, all these things were destroyed. None of the switches were there. Huh, interesting. Yeah, it does go off. Good. And it's got 3 new knobs here, which do some very interesting things. I can't find my tripod. Here's what we got. 1, fairly limited bandwidth on the resonance, or the brilliance control, as it's called, which is your cutoff frequency of brilliance. Now, as you'll get an amazing range of resonance control. Here's your standard resonance. There's the range of our standard resonance, which it gets up to a place where it's canceling a lot. So you get all that range. Okay, now you get a whole different tonal range by moving this one that has a high pass filter on the parallel there. Kind of mellows it out by canceling the high frequencies. Now the third one here is a low pass, and it'll give you extreme responses there for Now, back those way off. Hear a fairly subtle change through that range. Bring it up to notice the difference. The range of sounds you get there. And you get there. I got it mixed with the organ right now, so I can throw the organ in there. You don't hear very much of the brass if you have these turned up, because it really kills the brass volume. So probably one great addition would be put a compander on it. Now you notice nothing. Strange, huh? It's kind of weird sometimes. Certain things you do trigger it into the self-resonance. It's very sensitive. You can get that one just right so you can kind of anyway, yeah. It's really loud. I'd like to put a volume control on each of those individually so you can actually mix the levels in a more meaningful way. But I'm pleased with the tonal range you can get with each control. You get some really cool, you know, percussive. Mixed right. Yeah, you definitely get enough volume there when you... That's a kind of a cool analog kick kind of effect. Anyway, so yeah, the general string effects and things are all lovely. I had that weird problem with the decay because we're in solo mode. That wasn't the problem before. The problem before was you got, you know, two halves of an op amp, and their one half is, well, they're both doing the same thing, but they're doing it in different parts of the circuit. They're both just simple follower circuits. And for some reason, one of them just set there rock solid as the input would move, while the other one tracked with the input. The voltage was the same on the output like it should be. And it just all of a sudden started working as I was trying desperately to figure out what was wrong with it. And but it doesn't exactly work. They're not precisely matched. It's like 1.8 volts, 2 volts. There's a slight offset, but it does work. Now we have decay. Okay. These are delightful machines. They really do some kind of cool things in the realm of the divide down string. Doing what it should. I couldn't remember they had that. So the decay's off, it just bonk. very percussive thing. And the organ. What you can do with this thing, as you may remember or not, you can combine the brass and the organ. Those will turn on at once if you hit them both at the same time. There we go. And you get those effects. And over here, you can do organ and string. More subtle on the volume here. The organ's kind of loud. And then, of course, you can also combine all three. And you actually can get some good effects, but the whole thing goes through the piano's envelope. The percussion means nothing. However, the chorus does work. So, you get a mix of all the voices. These are a little quieter. My favorite, I think. Hard to play in this position, but anyway. You do get all those possibilities with this one. Now, if you put the brass with anything, though, it just, except for the, it'll work with the string. You just don't hear the actual voices. You hear the filter. You have it turned all the way up. Yeah, you do. They're just quiet. Before. Okay, they do work. I thought they did. Good, okay. And then you can combine the organ and the brass. But if you combine the piano and the brass, you get absolutely piano. Pretty much just piano bleed, I think, on that one. So pretty useless hooking those two together, but everything else does something interesting. So that's one of the coolest effects. This is a major enhancement, folks. I recommend taking any of these that have shot up front panels and doing that to it. Because that really does lend itself to the sound quality to get a resonance control at least on there, if not the 3-part resonance control, which we're just doing. You experiment with different high and low pass filters in the feedback loop there and get those interesting effects. Bob Weigel, Sound Doctor, and the ARP Quartet, one of the late 70s, 1979, I believe they made these things, and ARP didn't really build it, of course. It's a CL orchestra with another front panel.